Hello, and thanks for your time. The purpose of this video tool is to help national societies understand what is going on with this changing climate, how it may affect the work of the Red Cross, which are the challenges and which are the opportunities. My name is Pablo. I am originally from Argentina. I am currently based at Boston University and having the fortune of working with the Red Cross Red Crescent Center on Climate Change and Disaster Preparedness, which is based in the Netherlands but serves all national societies, especially those from developing countries. Over the next 30 minutes or so, we're going to learn the basics of the climate problem, what it means for the Red Cross, and what can we do about it. You probably have heard about global warming or climate change or the greenhouse effect. There's a lot of talk at all levels, from local people, fishermen, farmers, drivers, gardeners, to politicians, to United Nations personnel, who refer to a change. Things are behaving differently. And I wanted to start with this image, this sequence of images from a glacier in the Andes in South America, Llano Peru, just to give a sense of what's going on. 1987, we can see this glacier. It's on a lake. We can see a very clear vertical wall, little pieces of ice floating on the lake, pretty wide. The glacier is fed by precipitation, by snowfall that happens up in the mountains, and as it goes down there's also a partial melting, and this keeps the glacier in balance if the climate is constant. But if we look at 10 years after this photo was taken, you can see some very noticeable change. First of all, it doesn't reach the edge of the lake. There's no longer a vertical front on the glacier. There's much less mass of ice. If we think about a year ago or two, depending on when you're watching this video, this is so different. Look at this, it's barely a patch of ice. If we remember the contrast with what used to be less than 20 years before, the magnitude of the change is very significant. Now, we have to bear in mind that glaciers have memory. It's not so easy to change such a large volume of ice with just one of two unusually warm summers. This takes a long time of sustained change to create such magnitude of modification. In addition to the scientific interest or the noticeable awe that may be created by this is very relevant for people. People who live in the Andes, who need to drink water like we all do, they depend on a regular flow in streams that depends on a regular melting of the ice. What happens is that if this ice continues to diminish, when it disappears, there will be water in the streams only when there is precipitation. And that can be very dangerous. There's 10 million people or so depending on water that comes down from the glaciers in the city of Lima, Peru. Maybe not 10 million already, but pretty soon that's going to be the population of that city. What is going to happen to those people? A changing climate poses a very severe threat to populations worldwide. I'd like to come back to the issue of climate predictions. As you know, over the past decades, there's been a remarkable progress in our ability to collect information about the climate with satellites, with thermometers and pressures and balloons that detect what's going on. There's also a wonderful ability to store this information in computers, in hard disks, to process such information with increased scientific understanding of processes, what happens, what generates wind and ocean currents, and so on. And once we create this knowledge, including predictions, it's much easier to disseminate with new technologies, the internet and cell phones and publications and so on. Because we understand the climate much better now, that enables us to tell what is likely to happen in the future with the weather and the climate. And this occurs at a variety of scales, both in terms of space and of time. If we think of tornadoes, a very local process, very short term, there are areas where with 7 minutes anticipation we can say there are conditions for tornadoes, be careful, maybe you should go to the basement. With hurricanes, we're talking of longer lead, 3-5 days, and we know where a hurricane is likely to go and whether or not it's likely to grow in intensity because of water temperature. El Nino, you probably have heard, an unusual warming of the waters in the Pacific Ocean that happens to change precipitation and temperature in some areas with predictability. And what we care about, which is climate change. We're going to talk a little more about this shortly. Until now, scientists that have been developing this new knowledge and these predictions have been wondering how can we reach out, and one approach has been to just publish it or put it page in the web or announce it through the radio. And sometimes people don't get that information or don't understand it. This is a photo from my times as a doctoral student. My advisor, I was lucky enough to work with him. He's a paragliding pilot, and he took me up in the air in Zimbabwe for 40 minutes before we landed at a football field in the Limpopo, in the rural valley here. I was lucky enough to work with him, and he took me flying up in the air for about 40 minutes. We landed in the football field of a little rural school. And this, I think, this photo can be a wonderful metaphor of why some things don't work. If scientists dump forecasts, climate predictions on people who are not used to receiving that, it's like saying 2 guys falling from the sky. What is that information? What does it mean? Why should I trust it? Why should I do something about it? It's understandable that people don't respond to predictions as we think they should. We need to see how to reach them better. And in that sense, the Red Cross and Red Crescent societies have a wonderful capacity to reach communities in a way that is more likely to be successful. Okay, climate change. What's going on? The first concept we need to learn is that of the greenhouse effect. Just like in a car, when we leave the car parked in the sunshine and we spend 3 hours outside of the car and then we get in, most likely, if the sun is strong enough, inside the car is going to be warmer, hotter than outside. Why is that? The sunlight comes through the transparent glass, warms the surfaces of the car, the driving wheel, the seats, and that heat then wants to go away, wants to radiate out, and a portion of it is trapped by the glass. So the sunlight comes through the glass, heats the surfaces, and then the heat wants to go out and a portion is trapped. The same happens with the atmosphere. The atmosphere provides our planet with a greenhouse effect. And that's wonderful. Without the greenhouse effect, it would be very cold, like it is in the moon. Now, what is happening? The chemical composition of our atmosphere is changing. In particular, carbon dioxide, CO2, which is a gas that we are pumping up in the air because of cars and industries and deforestation and other activities. It's as if the glass were becoming thicker. With a thicker glass, the same amount of sunlight comes in, but a larger proportion of heat is trapped in the system. Therefore, we are retaining more solar energy, and as a consequence, the globe is very slowly warming up. On average, the global temperature has been going up. There's plenty of evidence of it. And that helps explain why in some parts of the world, especially in high mountains and in the poles, Arctic and Antarctic poles,